Nevertheless, the default, innovative, and practical method of modeling composite steel sections is what is called implicit modeling. In implicit modeling, there are no elements that model the actual geometry of the steel section. Instead, the geometry of the steel section is represented by the location of the steel springs within the elements. Implicit modeling is not exclusive to composite sections. In fact, bare steel sections can also be modeled implicitly by specifying the encapsulating material as filler. In this case, only filler elements that intersect the geometry of the steel section are preserved by the solver, while the unused ones are eliminated. Redefining the component mesh to consist of finer elements results in a mesh that more closely resembles the geometry of the encapsulated steel section. If the user needs to modify the mesh for the steel section, or define a different steel section mesh independent of the surrounding concrete mesh, in cases of composite sections, explicit modeling is required. The user can directly draw a bare, explicitly defined steel section from the Draw Steel column or Draw Steel girder commands in the Draw tab. In composite sections, which are implicitly defined by default, the component can be selected. Then, from the Additional Tasks menu, the Extract Steel Section option can be used to separate the embedded steel section and the external concrete into two independent objects that can be meshed separately. Explicit steel sections also allow the user to define a different mesh for the web and flanges of a steel section if needed. To specify the mesh after extracting the steel section, select the elements of, for example, the flange, and navigate to the Additional Tasks menu. Remesh selected elements. The two methods of modeling steel sections give the user the necessary tools to fine-tune their problem accuracy and balance it with computational efficiency to suit their problem requirements and hardware